this one, the angle is changing, right? So it starts off like this, and it's rotated to this, okay? So let's think about this. It's got a diameter of that. So here's the thing. Let's look at the direction of it, right? So there's a magnetic field into the page. So here's this magnetic field into the page. Let's draw a picture of that. Helps me to do this. Gives me time to think about how I'm going to explain this problem while I'm drawing X's on the page. All right, there we go. Okay, so what's happening here is that we are actually increasing flux into the page. We're gaining flux into the page. And the reason is that there's fewer flux lines going through the loop when it's like this, more flux lines when it's like this, okay? So we're gaining flux into the page, and so what we do to oppose it is we create out of the page flux. If you gain it, then you oppose it. Okay, so you oppose it by creating flux out of the page. And the way to create flux out of the page is for the current to flow anti-clockwise. Whoops. Anti-clockwise, is that right? Yeah. Yes, that creates flux out of the page. Okay? So anti-clockwise is the direction, right? Okay. Now let's take a look at the voltage here, right? So remember that if we look at this, we want to do the flux is B dot A, right? Which is BA cos theta. So we got to make sure we're using the right angle here. So let's look at this from the side. Let's imagine that we're looking at this from the side, okay? And these magnetic field lines are like this, into this page, right? If I could draw a picture of this, okay? So the flux line, the field lines are into this page, and we're going from 54 degrees, which is like this, to 23 degrees, which is like this. Kind of. That's more like 30 degrees, okay? But what you got to understand is that the area here is, and we could draw this area vector any way we want. I'm going to draw it this way. It makes it simpler, right? The area vector is at right angles to this. So here's our area, okay? Notice that this angle here is actually, that angle right there is actually the same angle as this. Is that right? Are those the same angle? Yeah, they are. Because if this one goes to 0, that one will also go to 0. That is, if we lay this down flat, if we lay this thing down flat, this guy is going to be parallel to that, and that'll be 0 degrees, okay? So this angle, that 54-degree angle, is the angle that we want to use, okay? Let's draw a picture here. Again, here's our area, right? The magnetic field line is like that. You can see that that's angle and this angle are congruent, okay? So what we have then is our EMF is going to be, in this case, it's going to be N single loop, so 1. It's N, B, A, cos theta minus B, A, cos theta, right? Now, the magnetic field doesn't change, and the area is not going to change, but theta changes, right? So this ends up being N, B, A, cos theta 1, or final, right? Minus cos theta initial. It's always final minus initial, okay? And then that's, of course, over time, right? Okay, so let's see. I think we have everything we need. So our EMF is equal to 1 is our number of windings, right? Our magnetic field is 12 Teslas. It's a big magnetic field. I just want you guys to know that. Oh no, it's got a diameter of 0.21. So it's going to be pi. The area is pi times 0.21 over 2 squared, because it's the diameter, right? And then it's going to be the final, so cos 23 minus cos 54. And then this is all divided by 0.015. 0.015. Okay. So I think we've got it here. Let's try it. Okay, I'm going to actually use the fraction thing here. So 1 times 12 times pi times parentheses 0.21 divided by 2 squared times parentheses cos 23. Quick check. Am I in degrees? Yes, I am. Oh, no. Oh, dear. That wasn't clever. Okay, so cos 23. Okay, I need to insert minus cos 54. Okay, and then the denominator is 0.015. Let's see if we have a syntax here. Ooh, we have the right answer. Who'd have thunk it? 9.219. 219 volts, or about 9.22 volts. Okay, and it's anti-clockwise because we're gaining flux into the page, so we create flux out of the page, right? So it's going to be anti-clockwise. All right.